So we're going to start this graph just like the other graph. I have my paper horizontal. I drew an X and a Y axis, and I drew my 5 line segments. I went over it with a colored pencil just to make it darker so that it would show up. Across the bottom, you can't see, but the X-axis is going to have time, and the Y-axis has speed in meters per second, or velocity. Time would be measured in seconds across the bottom, the X-axis. This is a speed versus time graph. Since I graphed speed on the y-axis and time across the x-axis. Or let's take a look at what the slope is for this graph. Our formula for slope is it's rise over run. And so on the rise of this graph, we have velocity or speed, and the run is time. So if you take any segment of that, divide speed by time, you would get acceleration. So this graph is also known as an acceleration graph. So speed versus time, or an acceleration graph. Usually we'll just call it an acceleration graph. So let's take a look at our 5 line segments. A flat region on an acceleration graph is not the same as a flat region on the speed graph. But take this back. This section is not increasing or decreasing, but it has speed. Go back over to that y-axis. It has speed. It's just the speed is not changing, but the object is moving. It's just moving at a constant speed. So horizontal line on an acceleration graph just means that the acceleration is 0, but the object is still moving. If an object was not moving, look where I'm shading the line, it would be right here on the x-axis where 0 would be the speed. So to not be moving, you'd have to be down here. And I'm writing not moving underneath there, but you can't see that. Now let's look at our lines over here where they're increasing. So these two going up in the positive direction means that the object is accelerating. So its speed is moving faster and faster. When you have a steeper slope, you have a faster acceleration, like in the second segment, but if it's a little bit less of a steep slope, then you have a slower acceleration. Now over here where the lines are going down, we have a deacceleration. That means that the speed is decreasing and eventually we're moving to a stopped position. So you have a negative acceleration for those two. Where the slope is steeper, you have a greater deacceleration, and where it's less steep, it's not accelerating at quite the same rate. So we got slowing down faster at a faster rate, and then slowing down, but not quite as. Anytime you have a straight line on this graph, you have a constant acceleration. If you have a curved line, you actually have you have not a constant acceleration. Your acceleration is actually accelerating, if that was something that you could actually say.